Now in this lesson, we're going to take all the things that we've been talking about in terms of logic. Those are our simple statements and our compound statements, our ands and ors or conjunctions and disjunctions, our if-thens, our conditionals, and our if and only ifs, biconditionals. We're going to take those along with truth tables, and we're going to look at valid and invalid arguments. Now there are two parts of every argument. And kind of think about an argument like a jury trial. So you know that in a jury trial that you have attorneys and they're making arguments. Now they're making arguments on different sides, and they're hoping that the jury will come to a certain conclusion based on those arguments. Now in the argument there are two things. There are premises and then there's a conclusion. Now in order for the argument to be valid, the conclusion must be true if the premises are assumed to be true. So think about this idea of valid and invalid arguments, somewhat like a jury trial. If you have a trial and you have a defendant who's on trial for a certain crime, you're going to have both a prosecution team and a defense team. And both of those teams are going to set forth some premises, some facts or some things known to be true or assumed to be true. And then that jury is going to go back. They're going to take the set of premises that they've been given, and assuming they're true in one way or the other, they're going to come to a certain conclusion. Now, if they assume that the defense team has put forward the premises that are true, they're going to come back and say that the defendant's not guilty. But if they assume that the premises put forth by the prosecution team are true, then they're going to come back with a verdict of guilty. So based on what they know or assume to be true, they'll come up with a certain conclusion. And so that's exactly what we're doing here. We're going to look at the premises and we're going to come to a conclusion. And we're going to assume that the conclusion must be true if the premises are assumed to be true. Now, if an argument is proven to be false, it's called an invalid argument, or it's also called a fallacy. So here are the steps for testing the validity of an argument. And this is going to be very much like what we've already been doing within this logic chapter. So the first thing we're going to do is take our compound statement, break it down into simple statements, represent them with letters. We can use P, Q, and R as we've been doing, or you can select any letter to represent each simple statement. Now we're going to write our premises and our conclusion symbolically and as a conditional statement. And it's going to look like this format. If premise 1 and premise 2, then a certain conclusion. Now remember, in the case of making an argument, we're going to assume that the premises is true, or that all the premises are true. So we're going to make a truth table for this conditional statement, whatever it happens to be. And if the conditional statement is a tautology, the argument is valid. That is, if the values in the last column of the truth table are all truths, we're going to have a valid argument. Now, if there is a single false in our last column, it's not a tautology, and our argument is not valid. So therefore, it is a fallacy. So let's take one that has just a single premise, and let's prove that this is a true argument. So here's our compound statement. If the tumor is malignant, then you must have surgery. So this is an if-then statement made up of two simple statements. If the tumor is malignant, and for those of you who are not familiar with the word malignant, that means it's cancer. If the tumor is malignant, then you must have surgery. Two parts. First part, P. Second part, Q. We've got two simple statements. If we know that the premise is true, the tumor is malignant, then our logical conclusion would be you have to have surgery based on this statement. So we can write this symbolically this way. If P, then Q. If P, then Q. Now this is our typical conditional statement we've been working with all along. And P known to be true. And P true. So we've got if P then Q and P, therefore Q has to be true. That means therefore Q. So take a look at our original conditional and then our premise and our conclusion. If the tumor is malignant, then you must have surgery. The doctor says the tumor is malignant. The conclusion you come to is you must have surgery. So if P then Q and P, therefore Q. This notation, and what this means is now look at that conditional statement we have. If P then Q and P, remember we are assuming here that this is true. Therefore Q or then Q. So if all of this is true, then this has to be true. So in order for this to be a valid argument, our last column of our truth table must be all true. So let's take a look at the truth table we would do for this. Now this part is exactly what we have done before. So I'm going to write out all the parts I need. So look at what I've written here. So here are the columns that I need. Simple statement P, simple statement Q. Conditional, if P then Q. But remember, we said not only if P then Q, we said and P. The doctor came back and said, yes, it is malignant. So remember, P was, if it's malignant, Q was, you'll have surgery. The doctor came back and said, and it's malignant. So that's the and P part that you see right here. And now we're coming to the conclusion, well, you have to have surgery. So if all of that is true, then Q. So we're going to go about this really just exactly the same way we've done before, just filling in our normal way of filling in a truth table for two simple statements. Two truths, two falses, true, false, true, false. If P then Q, false only if P is true and Q is false. So true, false, true, true. Here's the only place where the antecedent is true and the consequent is false. So that's true, false, true, true for that third column. Now we've got to look at if P then Q. So here we have an and statement, and in order for an and statement to be true, a conjunction, both parts have to be true. So we look at the if P then Q, here it is, and we look at the P, and if they're both true, we'll write a true. So the first two are both true. We've got a true, then a false here, so that's going to be a false. A false and a true, well, that's going to be a false. And a false and a true, and that's going to be a false. So we only have one true in that fourth column there. But let's look at this last part. And really, I need to put the brackets here, because remember, we have a certain order we have to follow, and all of this has to be true before we conclude that Q is true. So we look at the if P then Q column, and P, so this column we just did. And we're going to look at the Q column, which is here. And this is a conditional. So a conditional is false only when the first part is true and the second part is false. Here's the first part. True. True would be true. Well, if the first part is false, you always have a true, regardless of what this is. False, then true. Again, we have a true. And then false, false. We have a true. Now, remember what we said. In order for this to be a valid argument, then that last column has to be all true. That's the tautology. That's the phrase. That's the term that we use when the truth table has all truths. And so that means our conclusion is true and our argument is valid. Now, that seems like a lot of work to go through and prove this statement to be true, because this is one of those cases where it's pretty obvious. If the tumor's malignant, you have to have surgery. The doctor says it's malignant, so you have to have surgery. Well, arguments become more and more complex. Go back and think about the jury trial that we were talking about. There are going to be a lot of arguments. If this and this and this and this and this, then this. Or if this and this and this, or this and this and this, then this conclusion. So they can get very, very complicated, and in the case of a complicated argument, the symbols will help us come to a conclusion.